want to cover today is how to determine an exponential regression. And we're going to follow procedures very similar to what we did when we figured out a linear regression. So to refresh, and I'm not going to do this up on the calculator, but when you see what I use when I use the calculator for the exponential, we're going to do a lot of the very similar steps. If I wanted to figure out what's the linear regression for this table that's comparing fat to calories, when you input your fat into L1 and calories into L2, the equation that you would come up with for the line of best fit is such. Your correlation coefficient, which is R, is 0.97, which is very good. You want that to be as close to 1 or -1 as possible. If I wanted to figure out what 40 grams of fat would result in terms of calories, I put the 40 in for X in my equation to get Y is 663.05. And then finally, if I wanted to know how many grams 400 calories would be, I put the 400 in for Y, and I get X is 17.57. Now, what we want to do today, though, is do the same process, but determine is if it's exponential, and if so, what's that exponential equation? So, I have a situation where I have a number of months and views of a video. And hopefully you can see that the table is growing at something other than a constant rate. Remember, a linear relationship, growth is at a constant rate. Okay? Exponential, growth is very, very quick, or decay is very, very quick. All right? And so hopefully you can see that even though the months are going up by 1, the views are going up significantly. So we're going to input all of this data, and I'm going to show you that in a moment, into our calculator to get our line for our exponential equation to be so. You'll see that my variable for X is now the exponent. Now, why is exponential preferable to linear? Well, when you see that our coefficient of R is 0.9999 for the exponential, which is extremely good, versus 0.86 for linear, obviously the exponential is much stronger. And then how would I find the second month? Well, I would use the equation that we figured out and use 2 for the exponent to get 3515. Now, let me show you how that's done on the calculator. We are going to go to our calculator. We're going to hit stat and enter, which gives us L1 and L2. I'm going to put in 0, 1. Now, I'm skipping 2 because she didn't figure out how many views there are in the second month. So you can't put in a 0 because that's not correct. That's a data point. So you just omit it. Then I'll put in my additional data. Now, what we said is we thought that this was going to be exponential. So we're going to do something very similar to what we did. Is we're going to go over to calc. Instead of hitting 4 for linear regression, what we're going to do is go down to 0 where it says exponential regression, hit enter, and that's how I got my equation that we did before. Now, there's my R. If I hit linear regression, and ask for that, you'll see that's where I got my R. Nope. Sometimes the calculator doesn't move as quick or too quick. So now if I did the linear regression, that's where I got the R of 0.86, not as favorable as the other one. Now, what I'm going to do, and I'm going to write this down for you in a moment, is show you how you would do a scatter plot of this. All right? So I'm just going to call back the exponential equation, and I'm going to show you how you do a scatter plot for that. Now, to do a scatter plot, and all of this is going to be written down on the next page, so don't worry about it. We hit second, y equals, and I want to make sure my plot is on, which it is. Okay? So I'm good there. And then I can get out of there. Okay, you'll see that little quit button get you blank screen. Now, you'll notice that the table of values, my x values go from 0 to 6, but my y's go from 843 to 62,381. So I need to change the windows, which I've done here, to go from 0 to 10 and 800 to 63,000. Okay? And maybe I'll even make that a 65,000 just to give me even a little bit more room. Point. One of the problems with demonstrating stuff on the calculator is it's a little bit tedious. All right? Now, I then go back to see any graph. I just hit the graph. There's my scatter plot. It looks exponential. Now I want to compare my equation to the scatter plot. So I'm going to go into y equals, and I'm going to put my equation in there. But instead of retyping it, I can have the calculator do it for me automatically. I hit vars. I go down to stat. I go over to EQ. I hit enter. And it throws it in there for me, and I just need to fill in the x for my exponent. And now I go back to graph, and you can see there's the equation I'm graphing versus the scatter plot, and they are matching up pretty well. Okay? So let's go back to our notes and fill in the next page. So to make sure the scatter plot is on, we're going to hit second, y equals, enter, enter, over, on. Okay? Okay? Now, as I said, if the range of the numbers is very wide, then I want to go in and adjust the min and maximums. So, how do I do that? I hit the window button, and then I alter the scale of the x and y min and max values. And then hit graph. That'll show me the scatter plot. Okay. Now, one thing to remember, how do you turn on your diagnostics? You hit second, 0, and then you scroll down to diagnostics on, and hit enter. Okay? Usually a couple of times. Now, if I want to see the graph compared to my scatter plot, then I want to automatically place the equation into y equals. I hit y equals, the VARS button, Then I go over to stats, EQ. Now, a couple of other points to just keep in mind throughout this. Number one, if you need to use the X and Y axes, then the scatter plot must be off. Now, another very helpful thing for you to know, especially if you're taking a long test or something and you're doing many different things, how do I reset my calculator? Okay, then that kind of gets rid of whatever's there. So how do I do that? I hit the second plus sign, I hit reset, or move down to reset, all RAM, and then reset one more time. Okay? The one thing you need to keep in mind is you need to turn the diagnostics on again. Because by default, they goes to diagnostics off. Don't ask me why, but that's the reason. All right, now, I want to do the next problem of the decrease in weight of radioactive material. So I'm going to do this up on the calculator, and then we'll fill in the note sheet. So always easier to clear the entire L1 and L2, because then that leaves out some data that could be not useful or extra data. So I'm going to put in my months, and I'll put in the weight. Now, if you look at this data, the numbers are not decreasing significantly or very rapidly. So it's a little bit unclear which one is a better fit, a exponential or linear. So that's what we're going to have the calculator tell us. So let's do a calculation of the linear regression first. No, let's do the exponential so that we can fill in the data. So for my exponential, you'll see that R comes up at 0.98, which is negative 0.98. I'm sorry. Gotta watch that negative sign is not very clear there, but you see it. And that makes sense because the data is going, as the months go up, the weight goes down, so it's a negative relationship. And actually what it would represent if it's exponential is exponential decay. So this is really strong, but let's see what it looks like for a linear regression. See which one is preferable. Excuse me. And you'll see linear is negative 0.95, so the exponential one is definitely what we want to be using here. So I'm going to go back to it, because we're going to show you how to use it again in a moment. So filling in our data on our notes. Now we know it's an exponential regression. So my equation is y equals 46.22 times 0.833 to the x power. Y is exponential preferable because it's negative 0.98 versus negative 0.95. Now, what would it be after 10 weeks? Well, the weeks is my exponent. So I put 10 in for my exponent to get about 7.4. Now, I want to know when it will hit 5 grams. And you've seen this type of problem before, where now we want the calculator to figure some future number for us. And you saw this with the exponential growth and decay problem. So since I'm looking for the exponent, I can't solve that, or you have not learned how to solve that algebraically. That's in Algebra 2. So we use the calculator. And how do we use the calculator? We have the calculator in our y equals. We put in the equation that we had come up with. Okay? And now we want to call up the table of values to see that in week 13, it goes or hits 5 grams. At the end of week 12, it's still 5.1. So then we can answer our that question there, and I'll put that answer up there in one moment because I just want to clear this for our next example. Okay, so going back, after how many weeks? After 12 weeks, or in week 13, it hits 5 grams. Okay? So let's go to our last example. So we have population and growth. So what we're going to do here, instead of putting the full 1,800 in, what we're going to do is let 1,800 be 0. And since it's going up by 20, we're going to count by 20s. Sorry, but there's no shortcut way if I'm doing multiple examples to come up with inputting this data without it being a little bit of a tedious exercise. Please remember to input your data. Be careful when you input your data. Go back and check it over, because if any number is incorrect, it changes your answer. Sorry for the total silence here, but unless I had a good joke or something, there's nothing much I can do. Some level will screw up my input if I try to tell a joke. Okay, now everything is in. Stat, calc. Let's take a look at exponential. Enter. And there's my equation. Okay? 0.98, that's very good. So now let's go back to our note sheet. So I get y equals 7867.85 times 1.02 to the x. R is 0.98. Now I'm going to do answer D first, and then we'll come back to C. So D, since it's asking you for the growth, well, 2020 would be 220 as my exponent based upon my inputs. So it would be 613, 612 if I did the math correct. Now, when will the population hit 500? So that means I'm looking for the exponent, which means I've got to go into y equals. All right? So let's do that. I got to clear out the old one, put in the new. Put put in the x. Now I want to go to my table of values. Now, here's part of the problem. We were counting by 20s, while the table is counting by 1s in the x. So this could take us a long time. So what we want to do is, let's go to our table set. Now you see where it says that little triangle is delta, the Greek letter delta, which stands for change. So that means my x values are changing by 1, which you can see over here on the table. I'd rather have them change by 20 for the moment, because that's what we were counting by. And I'm going to have them start at 0 as opposed to 7, because that's what we started with. Okay? Now I go back to my table. Now, when will I hit 500 million? Well, now I'm going to keep counting, keep going. And you can see it's somewhere between 200 and 220 years, right? Because I'm at 397 and I'm at 589. So now I go back to my table set. And what I'm going to do is I'm going to get clever and tell the table to start at 200 and go back to having it count by 1s. And now I can see that somewhere in the year, or 212 years from 1800, I'm going to hit a population of 500 million. Okay? So, when will the population reach 500 million? 212 years from 1800. Okay? Which kind of, if you think about it, makes some sense. Right? That's 2012. Because in 2020, which is what D is, I'm above 500 million. So that stays up in line. So to recap, what we did today was an exponential function and how we figured out the equation for it and other pieces of data.